So guys, as mentioned, for modeling such as ceilings in your projects, for example type 1, 2 or whatever, I want to model these types that we usually use them for the intensity of the installations. As you can see in type B, we got the pipes of the lightings, but here we got a net that is different to the other one. Anyway, I don't want to get through details. Let us start. So for creating or modeling such a ceiling, again I want to emphasize that these descriptions, these explanations in these video tutorials are just some examples. I mean, you may find many other different types of ceilings, since in modeling using the BIM process, the needs of the employers are at the priority. So everything is up to your goals and to your clients. So if these details are not considered in your projects, there is no need to model them. And I should say that it's just waste of time. So firstly, you have to check the goals and the purposes of the ceilings, and then choosing the type and decide on whether to model the details or not. Sometimes we need to schedule or provide a scheduled table out of everything. But I should say that modeling these details are not helpful for clash detection. However, I have talked more about these in the course of BIM. Here, for instance, we got the dimensions and distances defined for the pipes, for the installations. And as you can see here, there are some connections that their positions may be changed, okay? And does not matter. This does not matter. Or sometimes, for instance, the dimensions of the ducts may change, that we can remove or add more connections. So I don't recommend modeling these details for clash detection. But for schedule table, yes, you can use them. Everything depends on your needs. Anyway, let us model it and then get familiar with the way that we model them. Here we got some tables as well. We got the distances, we got the dimensions, the thicknesses for the underlaying part or section or behind the ceilings, and also the type of the material, the thermal layer, and also if the surface has got some holes on, as you can see, their thicknesses are defined to 9.5 and 12.5 per millimeters. Great. And here we got the connections, and also this one, or the suspension rod, and actually here we got the connection component that is going to be bended in two types, halved and perfect type, as you can see. And as you can see, in some of the cases we need to use the halved type, and in some others we need to use the perfect one. So, and it depends on the needs or the positions that we are using them. Anyway, forget about it. We just want to model these. So firstly, the first task here is to model these families, each of these components, modeling them, and then we can just install them, as you can see. But before that, I want to save this file as, let me assign a name for it, ceiling. By this way I click on save, since I don't want to manipulate the main file. Then let me adjust the scale of the file here. First of all, Let me find a simple thing. For example, the thickness of the ceiling. Let me check it out. Uh, Here we got the panel. As you can see, it is being shown isometrically. The thickness, not 0.17, 18, 15, and 12.5. I want to consider 15 for the thickness of the panel, 1.5 centimeters. I draw a line using ortho or F8. Watch this, 1.5 centimeters by this way. Enter, then I move it. Control A to select them all, but I deselect this line. Align, okay. Then I align this with the other line. Okay. Then I minimize the scale. So right now it is more realistic. For instance, if I measure the distance of here, as you can see, 47 centimeters from center to center. For the profiles, for the loading profiles, 750 in 1000. But here that I'm measuring this distance, it is not similar to that. Let me measure this, 5 centimeters, and 10 centimeters here to the edge of the wall, and let me measure the distance of here. Let me see. Hypothetically, and as you are concerned, here the geometries are being shown schematically, okay? 12 centimeters. Anyway, the scale is almost okay. But here we want to model each of these components one by one, and I have revised the scale of these, and I have searched for the real dimensions. Watch this, here we got the connection. I select this and then I make a copy. I open a new template, Ctrl V to paste it here. Enter, then I select them. I choose the center, hold down shift, mid between 2 points. I move it, shift, sharp, and 00. I set the units per meters. Control S to save this file as. Let me assign a name for it. Here, for example, I can name it connection 01. Well done. I copy the full path, full file path, then I close this file, new, generic model family, open. Then from insert tab, import CAD, I import the CAD file or the connection, meter and black and white. Then I want to measure the distance. Let's see, 34 millimeters, as you can see. So we get back to here, drawing a reference plane, 34 millimeters, and I assign a name for it, A, to convert it to a work plane. We open the plan view, picking extrusion, setting the work plane to A. Then by using pick line, I click on the boundaries to draw the connection. Watch this. And we don't need any parameters here since they are fixed and they don't need to be changed, or they are not provided parametrically. We click on the lines, then we trim like this way, split and then trim. Well done. We get back to this part, to this file. Watch this, the health part and the perfect one. That at the center the geometry is different to others. Watch this. Firstly, I want to draw the rectangle here and then I trim it. Let's see, I delete these by this way. 4 and 4 again, deleting this. Then I pick arc like this way, and then line down. I delete these and then I trim them. Well done. I draw the circles and the rectangle, one for the radius by this way. Finish. 2 for the thickness. Watch this. However, I should minimize it. 1 millimeters. 1 millimeter actually. Then we get back to the plan view. Then these parts are left. I draw a reference plane here. Watch this. To bend this like this way. B. Then I draw a section line here like this way, 1 to 1 for the scale. Then for the section 100 like this way. Watch the continue in the next session.